Okay, let's talk about angles. Like everybody's had high school geometry, you know what angles are, but here is a formal definition. You can read this if you want, but you know what an angle is. Two rays come together with a common vertex, and we call the angle this area in between here, this region in between the two rays. Now, that's the high school geometry version. We're going to take things up just a little notch here. We're going to say angles have direction. So angle for us will be, we start with some initial ray that we call the initial side, and the angle is rotated toward the terminal side. So an angle rotated counterclockwise is different from one rotated clockwise. Direction matters. And we're going to take it as a convention that anything rotated counterclockwise will be a positive angle. Rotating clockwise will be a negative angle. So an angle in standard position, if we throw it in an XY coordinate system, standard position means our initial side is along the x-axis, and then our terminal side is wherever. So this would show a positive angle because we're rotating counterclockwise. And of course, we know what a right angle is, some special angles. We know a right angle, you might want to write that down if you don't know that, is a 90-degree angle. We also know if you rotate 180 degrees, forming a straight line, we call that a straight angle. Okay, some special angles. We know, again, there's going to be a whole lot of we know here in this first chapter. We know that we can number our quadrants in the XY plane, 1, 2, 3, 4, going around counterclockwise. So some of our special angles are what we call the quadrantal angles. They mark off the quadrants. 90 degrees, a right angle. 180 degrees, which we call a straight angle. 270 degrees, 3/4 of the way around. I don't think this one has a special name. If it does, I've never heard it. And of course, if we rotate all the way around a complete circle, we would get 360 degrees. Okay, now, an angle is determined by its initial side and its terminal side. Well, what if we have two angles with the same initial and terminal sides? We would call those coterminal angles. So what does this mean? Imagine if we had, let's draw a little picture here. Here's our XY coordinate system. And let's draw this in black. Say we have here some angle rotating this way that's a 30-degree angle. So this is my initial side, and this is my terminal side. Well, I could get to the same spot if instead I rotated all the way around 360 degrees plus another 30. So all the way around 360 plus one more 30 is 390 degrees total. I still have the same initial side. I still started facing this direction, and I still, at the end, am facing this direction. Same initial and terminal sides, but those are different angles. Like imagine sitting in your chair and rotating 30 degrees versus sitting in your chair, doing a complete spin, and going 30 more degrees. At the end of the day, you're still facing the same direction in both cases, but here you're a little more dizzy. You spun around more. So they're not the same angle, we just say they're coterminal. Coterminal angles start and end at the same place. We could also, instead of rotating a positive direction, I could have rotated around in a negative direction. So if it's 360 all the way around, I didn't go quite negative 360, I was 30 degrees short, this would be negative 330 degrees. Still started and ended at the same place, but it's a different angle. Now I'm rotating clockwise. Or if I wanted to, I could rotate around 7 times plus another 30. So maybe my angle is 7 times 360, whatever that is, plus 30. I'm still in the same place. Now, why do we care about this? These are all different angles, but they all start and end in the same place. Trig functions treat these all the same. As far as sine is concerned, the sine of all of these angles will be the same. That's why we care about coterminal angles. Okay, and again, you may remember these terms here from high school geometry: complementary and supplementary angles. We say two angles are complements of each other, or complementary angles, if they form a right angle. So maybe we have here's two angles. Missed a little there. Missed again. Let me start from here. Maybe 20 degrees and 70 degrees. Maybe we call this guy angle alpha, and we call this guy here angle beta. Well, alpha plus beta is 90 degrees. Those are complementary angles. They form, if we squish them together, a right angle. So alpha was rotating here, beta was rotating here. But they don't have to literally sit next to each other. I could have maybe a 40 degree angle here and someplace else a 50 degree angle. Those are complementary angles because 40 plus 50 is 90. So they might sit right next to each other and literally form a right angle, or they might just be two separate angles. Similarly, supplementary angles form a straight angle, 180 degrees. So I might have here maybe this alpha is 130 degree angle, and then maybe beta lives in here, and he's a 50 degree angle. Well, altogether they form a straight line, a straight angle, 180 degrees. But again, they don't have to literally be sitting next to each other. I might have 120 degrees and a 60 degree angle. And these would still be supplementary angles because they add up to 180.